So this problem adds to or elaborates on the previous one, 22.25, I believe it was. So this is a Harris survey of smokers, and they took 1,010 smokers and asked them a single question: would smoking probably shorten their lives? And 848 of them responded with a success, meaning yes. They said yes, they agreed with that. So Harris announces a margin of error of plus or minus 3 percentage points for all the samples of about this size. Opinion polls announce the margin of error for 95% confidence. So the first question is, what is the actual margin of error for the large sample confidence interval from this sample? And we got that from actually the previous problem. So we know that this is roughly 2.3% here. So we know that is roughly 2.3%. So it's somewhere between, I believe we got somewhere between maybe 84 and 86% was the range, including the margin of error. So now they're asking the question, well, the margin of error is largest when the sample proportion is equal to half, or 0.5. What would the margin of error in percent be if the sample had resulted in the sample proportion being 0.5? And this is simply redoing this calculation at 95% confidence, but having a sample proportion of half, or 0.5. So we do the same calculation. We use the same formula, m equals z star times the square root of p hat times 1 minus p hat over n. And I believe the z star we calculated to be, I think it was 1.960, but we can actually confirm that by just bringing up our table here and looking at the value at 95% of p. So here's our 95%. We go down here and it is 1.960. So that's the value we're going to put in for our critical value, 1.960 or 1.96. And we're multiplying that by the square root of, now our new p hat is not going to be the one we calculated in the last problem. Our new p hat is going to be 0.5. And this is going to be times 1 minus p hat, which again is 0.5. And I'm just doing this in a different color so that you can see where the difference is in this calculation. Now our sample size is still the same size, 1010. So everything else is the same. The only thing that's going to change is our p hat. So let's do this calculation. So we end up with 1.960 times the square root of, and this is 0.5, and then 1 minus 0.5 is just 0.5 over 1010. And 0.5 times 0.5 should give us 0.25, but let me double check. Sorry, I'm trying to type the numbers in here and I'm typing them incorrectly. So here we are. So 0.25, so 1.960 times the square root of 0.25 over 1010. Well, 0.25 divided by 1010 is equal to, and I'll just put it over here, 1.960 times the square root of, and this is actually 2.48 times 10 to the minus 4. So it's a pretty small number, so we're going to take the square root of that number. So we can take the square root of that. I'm going to actually take the square root of the whole number that was calculated, and what I end up with is 1.960 times, I'll just put this as an asterisk, times 0.016 is the number that we get. And so if I multiply that by 1.960, I get the margin of error is equal to 0.03 or 3% roughly. It's closer to 3.1%, but that's okay. So we get about 3%. So that's a difference. So we went from 2%, we went up a percentile because our sample proportion actually was different than the sample proportion that we used before. So that actually had an effect on the margin of error. And I believe that that's kind of what they're getting at here, is just showing you that if these values do change, that the overall margin of error is impacted by those changes. So part C asks, well, why do you think that Harris announces a plus or minus 3% margin of error for all samples of about this size? Well, it was actually 3.1. They're actually saying plus or minus 3% error because that's actually what they calculated with a 0.5 sample proportion. So they're giving that margin of error mainly because we came up with that, we calculated that using the statistics that we had.